All right. So I'm going to post homework 6 later today. In fact, I'll do that just right after class. I'll post homework 6 onto Blackboard, and that needs to be submitted by Monday. So it's a relatively quick turnaround on that one, but the assignment is smaller in scope than some of the others have been. And then also, I introduced the project in the video from last Friday's class. So if you didn't watch that, you really, really need to. The project is posted on Blackboard. It's critically important for you to begin that early, because the students who do well are the ones who take some time to think about and digest it and gather data and work consistently. And the students who do poorly are the ones who don't read the assignment description until 2 weeks before the project is due, and then there's just not enough time at that point. So I may talk a little bit more about the project in future classes, but for the most part, everything I want to tell you about the project is included in that lecture video from Friday's class. The other announcement, by the way, is that they're doing the career fair today over in the rec center, and you should definitely go. It's until 4 o'clock, and I mean, if you're going to college, I assume that you want a job someday, and you need to start thinking about where you're going to work, what kind of position you'd like, the kind of company or agency you want to work for. So, like, even if you're not ready to start working and still have several years before you graduate, you should go to the career fair today and just see what's available, see who's interested in hiring, talk to them, get an idea about the projects they do, whether they have summer internships. So it's really a golden opportunity, and it would be super foolish to not go over there and see what's available. All right, we're going to talk about internal rate of return analysis today. And interest rates are a big topic in the news lately. The Federal Reserve has recently announced that they're going to be lowering the interest rates that they charge to financial institutions for short-term loans. And all of the other interest rates in the economy are kind of influenced by that, including auto loan rates, mortgage rates, and the rates that you're likely to earn on savings accounts, CD deposits, and so on. And so interest rates matter a lot. When you're borrowing money to do a project, if the interest rates are too high, your project may not be profitable, because so much of what you're earning will have to be turned over to the bank to cover the cost of interest. And if interest rates are low, then companies are able to invest in new equipment and new ideas. So interest rates are critically important. And so let's just compare a couple of different options. Interest rates have been really high recently. They're falling, but a couple of years ago, in February of 23, I took a screenshot. This was at Huntington Bank. They've got branches here in town. And if you wanted to borrow money for a model year 2023 car, then a 72-month loan, they were going to charge an annual percentage rate of 8.35%. So comparing that, there was another financial organization, Pentagon Federal Credit Union, had a 72-month auto loan for 5.84%. So it pays to shop around. Getting a lower rate can have a big impact on how much you end up paying in order to borrow money. And so let's just look at that specifically, the case of how interest rates matter, using an example of if we're going to buy a new F-150. And it seems like you can pay as much as you want for an F-150 in terms of being really high. I think maybe the lowest F-150 for new is maybe like the high 30,000s or something. But you know, like if you wanted an extended cab or leather or illuminated wheels for some reason, then you could pay over $100,000 for a pickup truck. So let's take a look at what would be the implications of borrowing $86,645, and if we were going to finance that with an 5.84% loan versus an 8.35% loan. So let's just say hypothetically that you're going to buy the truck in the hopes that you could generate some additional revenue. You know, it's a business opportunity where you're planning to earn an extra $1,500 a month. So should you do it? should you borrow this money? So let's take a look at what is the value of that money at the two different interest rates. Okay, so we have on a monthly basis, instead of, you know how usually when I put together a spreadsheet I say year, amount, and then PV of amount, I'm going to say month because this is a loan that has a duration of how many months? 72 months. Okay, so we're going to go 0 through 72, and we're going to find out if we borrow money from PenFed versus if we borrow money from Huntington Bank. How does that affect our overall profitability? Okay, so down through 72. All right. And every month, at the end of every month, I get this revenue that I've generated of $1,500 per month. So I get $1,500, and then I'm going to do what's the present value of the month if the interest rate is, okay, so above this I'm going to put what is the interest rate. The interest rate from Huntington was 8.35 per year, so equals 0.0835 divided by 12, because I want to know the interest rate per period. So 8.35% APR per year divided by 12 tells me the interest rate per period, which is 0.695% per period. Okay, and this is the Huntington rate. And then PenFed had a rate that they were quoting of 5.84. So 0.0584 divided by 12. So 8.54 APR per year, but I want to know the interest rate per period since I'm working in monthly periods. Oops, I need to define that as an equation. All right. And I'm also going to have the PV of the amount at the interest rate that's above it. Okay, so the 1,500 continues every month through 72. So I can just double click here. I don't even have to drag it down. If I just double click, then it does the same 1,500 all the way down, and then it stops when it sees the end of the list that's to the left of it. And I don't get any money at time 0. Well, I guess we could say that I have an outflow at time 0. I'm buying the truck, 86,645. So minus 86,645. It's an expensive truck. But I demand leather seats. All right, so equals PV. Okay, the rate I'm going to refer to is up here, the Huntington monthly interest rate. The NPER is whatever month we're in. Skipping over the payment field because anytime I put a number into this PV function, I want it to recognize that as a single lump sum future value. So I'm putting the amount into the future value field, and I have to do the minus of the amount because it's automatically going to change the sign anytime a financial function is applied. All right. And then last step here is to change it because I don't like the red. I'm going to double click to apply the function down through the entire cash flow sequence, and so what you see is that over the course of time that 1,500 becomes progressively less valuable with each passing month if you discount it to the present. Now let me do the same thing with the PenFed, and then I'm going to find the total. So equals PV using this interest rate, anchor the reference. The N is the month, skip over the payment, and have the amount in the future value field, and I need to indicate the minus of the amount. So let me again reformat that. All right, and apply it down through the entire sequence of numbers. Let me just do one more row here because I want to have the total be at the top. rather than the bottom. So equals the sum of all of these values. I'm going to do Shift, Control, and the down arrow, and it just takes me to the end of the list, which is kind of a nice shortcut rather than having to scroll down. Okay, so again, the way you do a total is equals sum. I kind of use the arrow key to get down to my starting cell, and then hold Shift, Control, and the down arrow. And it's just basically finding the end of the column. So it's summing together all of the inflows plus that single outflow at your 0. All right. So what this is showing is I don't think I've done this analysis right, honestly, because
I got something different.
Yeah, I think the formula on the PenFed one, you chose C5 instead of B5.
it needs to be the original amount, yeah, not the amount of the Huntington, yeah. All right, B. Yeah, I need to like put the actual cash flow sequence in there. Yeah. Okay. Hopefully things will look better now. Ah, yes. All right. So this makes more sense. Basically, what it's saying is, if you're borrowing money from Huntington, then you can't cover the cost of the vehicle with this new revenue that's coming in. That the overall value of this investment is negative. But if you borrow money from PenFed, you're earning $1,500 each month. You're giving a smaller part of that to the bank to repay the loan, and you get to keep the amount that you don't give to the bank. So like your share of the profits is higher when you started with a lower interest rate. So the PenFed had the lower interest rate per period. That means that those future revenues are being discounted less extreme than compared to Huntington. So if you have an option with a positive present worth and compare it to an option with a negative present worth, then let's just kind of interpret the results here and put it into the spreadsheet. You should borrow the money from PenFed because that will enable this project to have a positive present worth. But borrowing the money from Huntington Bank would cause the project to not be profitable, because so much of your revenue would go to cover the truck loan. So high interest rates can determine whether or not a project is profitable. And some companies aren't able to do new investments when their borrowing costs go up. They have to lay people off or just content themselves with existing equipment. But this demo, I think, helps to make the point that you should do it. You should do this project if you can borrow the money at an interest rate that where the cost of the repayment isn't going to be outweighed by the value of the revenue you're likely to earn. So that is part of what we're applying in the internal rate of return method. So IRR means the internal rate of return method. And what we'll be doing in the internal rate of return is trying to find out what is the interest rate that would cause the sum of the inflows and the outflows to be equal to 0. So in this example that we just did, I told you that this interest rate causes a negative present worth. This interest rate causes a positive present worth. But what interest rate causes the present worth to be equal to 0? And the reason why we want to know that is because that represents the rate of return for the project. So here's the formula for how to find the internal rate of return. And maybe that looks complicated. Don't let it panic you. Let me just discuss what this formula is saying. It's saying find out the interest rate which is unknown. So I prime is the unknown interest rate, and keep playing around with the unknown interest rate until the revenues and expenses equal 0. So the present worth of all of the revenues discounted to the present. So all of the revenues in the future, you're going to discount to the present with find P given F. So this is saying discount the future revenues starting at times 0 all the way through whatever year there is, through the K period. K would be the number of periods. Take the revenues and discount them to the present at some unknown interest rate, and you keep playing around with the interest rate until the revenues and the expenses, which also have been discounted to the present, are in balance and equal to 0. So back to this spreadsheet, like if I created another copy of it, let me do that. Right click, move or copy, create a copy. So now I've got the original, and then this is the copy. Okay, so in the copy here, I'm going to change this interest rate until I find one that causes this to be equal to 0. So what about 0.005? Okay, that's in the right direction. 0.006. Getting even closer. 0.0061. Closer. 6.3. Oh, I overshot it. 6.25. That's too much. So you remember that there's this goal seek that will allow us to specify that what I want is I want this to be 0 by changing the interest rate it's looking at. And so it'll vary the interest rate until it finds out what is the interest rate, in this case per period, that would cause the project to be equal to 0. So this was the interest rate per period. What is that in terms of an interest rate per year? So the interpretation of this is if the APR is more than 7.545% per year, then the project will not be profitable. So like if my revenue each period is going to be $1,500, and if the truck is whatever price it is, $86,645, kind of the break point in this example was an annual percentage rate of 7.5%. Any higher than that, the project won't be profitable. So that is applying this technique of looking for the graph here. The figure is showing what we're searching for in the internal rate of return is that unknown interest rate that causes the present worths to be equal to 0. When you add the revenues and the expenses together and they're in equilibrium, that is the unknown interest rate that we're trying to solve for. And if your interest rate's too low, you'll have a positive present worth. If your interest rate's too high, you'll have a negative present worth. And that's because revenue is generally in the future. And so when you have a high interest rate, what you're doing is you're discounting those positive revenues in the future and making them smaller. And then when combined with the present worth of the outflows, which is at time 0 and not subject to changes in value by the interest rate, then the overall sum would be negative. Okay, so what we're solving for, the internal rate of return, it can represent several things. I've just showed you in our example how it could be considered as the break point for whether a project is profitable or not profitable. It's defined as the rate that's earned on the unrecovered balance of an investment. So if you're an investor and you've loaned money or put it into a bank, then the rate of return that you're earning is what we're going to be trying to solve in the IRR method. If you're a borrower, then it's the rate on the yet unpaid balance. So it's the money that you still owe to them The internal rate of return is the rate that you are having to continue to pay. And then in terms of solving for it, it's the interest rate that brings all the inflows and the outflows to a zero balance. So here's the technique. If you're given a cash flow sequence, like here's a cash flow diagram, you discount all of the values, revenue and cost, to times zero. And you have to start with a guess of the interest rate, because you don't know at the outset of the problem what this unknown interest rate is. But you keep changing the interest rate until you find equilibrium between the inflows and the outflows, when everything's been discounted to the present. Now, it's a good tool for decision making. The whole point of this class is making decisions and choosing alternatives. And so if you have cash flow in and cash flow out in balance, then that tells you whether a project can be profitable. Because if you calculate the internal rate of return for a project and compare it to your borrowing costs, then your decision criteria would be don't accept any project where the internal rate of return is less than your borrowing costs. So you should only apply this method when you have revenues. You can't calculate a negative internal rate of return. That will be undefined. So it only applies in projects where there are future revenues to be considered. And it's most easily solved using Excel or graphically. You can solve it numerically by hand or putting into your calculator, but it's a little bit more tricky that way. And the decision criteria for IRR analysis is that if the internal rate of return is greater than the minimum attractive rate of return, then you should accept a project. So any project that yields more than the minimum is acceptable. Even if it's equal to the minimum, it's acceptable. But any project where the rate of return is less than the minimum attractive rate of return, you should reject the project. So remember that when you're applying a method, you need to state the decision criteria to have the final answer there. Now, a couple of warnings. It's okay to compare the internal rate of return to one project to the MAR, but you can't, for multiple alternatives, just pick the one with the highest internal rate of return. That will not identify the best alternative. So you shouldn't rank projects by their internal rate of return. And you'll see why in our next class meeting. The bottom line basically is that because some alternatives have different starting amounts, it's the overall profitability that tells you which option is best, not which project has the highest rate of return. You know, put simply, I'd rather earn 5% interest on a $10,000 account than earn 10% interest on an account that will only allow me to deposit $50. So you want to earn the most profits, not the highest rate of return. And sometimes those aren't the same. The other warning is that the internal rate of return is assuming that the cash flow that a project generates is reinvested back into the same project or another project that yields the same internal rate of return. So like that's true if you have a savings account and you're leaving the interest in the savings account. But some businesses, maybe like if you were going to open a hot dog cart, if you had some initial upfront expenses to start the hot dog cart and then you're getting these profits, you may not be reinvesting the profits back into the hot dog cart. So internal rate of return assumes reinvestment back at the same interest rate that the cash is being generated. We'll talk more about that. All right. So we have a in-class exercise today. Let me give you the paper for that. Okay, so this is pretty similar to the example that I showed you earlier with the truck. You got a cash flow diagram. These are years. The periods are years. So just make a year amount and then find out what is the present worth when everything's discounted at 7% versus at 8%. And then do goal seek to find out what is the interest rate that makes the present value added together of everything equal to 0. And when you're done with that, I'm going to show you how to use the IRR function. So if you discount the cash flow at 7%, then the present worth is $26,900. If you discount it at 8%, then it's negative $15,000. So it's kind of like a Goldilocks situation, you know, too high, too low. So we need to find what's the interest rate that's just right and brings everything into balance. So here I copied the cash flow sequence, and just as a placeholder I started off with 1%, and then I'm going to change that interest rate until this total is 0. So we do the what if analysis of goal seek. What if this was 0 by changing the interest rate? What interest rate would that be? 7.633. So that's the interest rate that we're looking for, the internal rate of return. So if I annotate this answer here, the internal rate of return for this cash flow sequence is 7.633%. And then we can verify that with the IRR function. So IRR is pretty interesting. All you do is say equals IRR, parentheses, and then you just put in all of the values, the original values, not the PV of the amounts, just the amounts themselves. And it says 8% because it's rounded off, but if I just increase the number of digits that it shows, it's telling me the same 7.633%. So the IRR function is basically in one go, it is converting the amounts into present values, and then it's solving for what interest rate brings the sum of the present values to equal to 0. All right, that's all the time we have for today. The problem that's on the back here that's related to a bond, we'll take a look at that in class on Friday. So remember that the homework will be posted in just a few minutes, and the career fair is going on over in the rec center. You should definitely stop by.